In this video, we are not just going to hack a Linux server, we are going to catch the hacker in the real time, build a live semi-alert and engineer this exact security operations center dashboard from scratch. Hey everyone, welcome back to the channel. Today we are doing a full red team and blue team home lab project. I'm going to show you how a brute force attack looks from the attacker's perspective, and more importantly, how to detect it is a security defender using a Splunk. Before we launching the attack, let's look at the lab architecture. I have a built and isolate a closed network using a virtual machine. Look, we have a Linux. It is a Kali Linux, obviously, for the attack. And we have a Ubuntu, it's a victim, and it is a Splunk forward. We have a Splunk server, also it is an attack machine, it's a Splunk forwarder, and it's a victim, obviously. Alright, let's put on our red team hats. We are currently inside our Kali Linux attacker machine to launch this breach. We are going to use Hydra, and Hydra is a very popular, very loud network logon cracker. Now a real attacker would use a massive password list like RACU.txt, which contain millions of compromised passwords. But to save time for this video, I've created a custom short word list. This is my word list. For example, it doesn't matter what's that, but includes our password of Ubuntu. Then, as you can see, I have a fully dummy password, and it's nonsense, but this is my password is admin with a small a. Let's launch the attack, and I'm going to tell Hydra to target the username admin, use the password list, and point it directly at the SSH service on our Ubuntu target. Okay, before that, I need to see what is the IP address of Ubuntu. It's that 136. That's fine. Okay, we start Hydra. Our username this, and the password and SSH 6. Okay, and if I enter this command, it start to check whole this file as a password with a admin username. Let's find out. As you can see, it find login admin and password. This is our password. It's so easy. And we found a valid password. Actually, the attacker has successfully breached the system. Right now, the attacker think they won, but what they don't know is that every single one of those failed guests just trigger massive alarms on the backend. Let's switch our back to our Splunk semi and catch them in the act. This is our web UI Splunk server enterprise console, and let's see if we can find the attack we just launched. In Splunk, we use SPL language, or Search Processing Language, to hunt for the threats. I'm going to start by casting a wide net. I'll type index. Let's see what we got. We found a lot of things, but we need to be more specific. Perfect. And it commands tell it to look especially at our Ubuntu authentication file by typing source var log aus.log. When we hit search, we see a massive wall of text. This is data, and every single action on Ubuntu server is logged here. But as a security analyst, I don't want to read a novel. I want to find their breach. So let's filter this down. I'm going to add the exact phrase Linux use when someone guessed and wrong password. This is the failed password. So okay, and we're going to 5 minutes ago, for example. This is our logs that the red team did with a Hydra. Now we are only seeing the failed password. We can clearly see the attacker's IPs here and the user that are targeting here. This is our source, this is the host. And now this is the great moment to show your audience how to handle messy data. Here's we have to find the user, but we couldn't find the word of the user from our data. That's why we use Rex. Now we only see the fail attempts. If you read the raw text, you can see the attacker is trying to log into admin here. But if we look on the left in the interesting field and select field, Splunk hasn't automatically extract the username for us. In the real world, logs don't always phrase perfectly. So as a SOC analyst, we have to extract it manually using a regular expression. Okay, I'm gonna add a pipe, type Rex. Okay, let's have a look what we got. We need to extract the admin after, before, and after, for, and from. Here, user, for example, W plus, from. Here we got the word. This is the admin. In this way we can extract easily. Then by user. Okay, now that we know exactly how to find this attack manually, we need to automate it. As a security engineer, you can't sit and stare at a search bar 20 hours a day waiting for an attacker to show up. You need to to do the watching for you. Let's build a real detection rules. Okay, here we have an interesting option on save as alert. In this in the top right corner, we're going to click save as alert, as I already show you, and this open up Splunk's automation engine. Let's give it a clear professional name. For example, SSH brute force text, and we change the alert to the real time because it's a brute force attack. And this means Splunk will analyze every single log line, the absolute microsecond it arrives from our Ubuntu server. Now here is the most important part of semi-engineer, the trigger condition. If we set it to alert on every single failed password, our security team will get flooded with the false alarms every time an employee taps their password. That cause alert exhausting, sorry. To catch an automate tool like Hydra while ignore normal human error, we are going to set the threshold to trigger only if there are greater than 5 fail attempts within a 1 minute windows. Greater than 5. Change it 1 minute. Is it 1 minute? And I think this is good. These options actually shows that you wanna show once when happened this attack, or every time that a brute force happens, it gives you an alert. I want to send me an email, a trigger alert, send an email. I want to keep everything as simple. Okay, we can see SSH brute force. This is our alert. After we click save, we have the engineer an active defense mechanism if a hacker tries to brute force our server again. An alert triggers intensely. Okay, as you remember, for this command, we have our raw data, and we've built our automate alert. But in a real security operations center, um, analysts and managers need to understand that threat landscape at a single glance. Reading rows of text take too long. We need to virtual this data and build a SOC dashboard. Right under the search bar, I'm gonna to click on the virtualization tab. As you can see, Splunk intensely takes the result from our states command and graph. Okay, maybe we can uh, also choose a pie chart. It doesn't matter. Now we have a highly readable visual uh, representing, showing exactly who that attackers is targeting. To make this permanent, we're going to click and save as, new dashboard. The title is overview and SSH plugins by target user, and this is exactly what is displayed on the massive TVs inside the site if a brute force attack happened. This chart spike in the real time, and the automates alert we built in a and before triggers, and the security team can intensely isolate the compromised server. So you must select yes. We just need the classic, and this is our dashboard, and this is all alerts that we have. For example, brute force detections, SSH brute force. We have a dashboard here. This is for another search. This is our graph, and just this. And that's bring us to the end of the project. Let's quickly recap what we accomplished today. We didn't just run a hacking tool. We built an entire end-to-end security pipeline. We used Kali Linux and Hydra to simulate the red team SSH brute force attacks. We configure a Splunk universal forward on a Linux server to ship, and then we act as a blue team engineers to hunt the threats, automate the alerts, and build this SOC dashboard. The biggest takeaway here isn't just knowing the Hydra command or Splunk queries. It's understand how the pipeline works. When the logs don't show up, in knowing how to dive into Linux permission and configuration files in what separates a beginner from the real security engineer. I try to put this project in the GitHub, and I put the links in the description section. It has my fully technical write-up and architecture details and the exact SPL queries I used today. Also, feel free to connect with me on LinkedIn. I'm always happy to chat with the other in the cybersecurity communities. If you found this video helpful, please hit the like button and subscribe for more hands-on security labs. And thanks for watching, and I'll see you in the next one.